Welcome back, guys. Today we'll be doing integration of partial fractions type 1. Now we'll be doing type 2 and type 3, but for today I'll be looking at when we have the first type where it's a quadratic in the denominator that is factorized and we express it as a partial fraction, then integrate. Let's get into it. Today, I will be looking at the partial fraction where we're splitting a fraction into two parts. Let's look at when we have, say for example, x plus 2 over 3. It's the same thing as x over 3 plus 2 over 3. So it's the same case with partial fraction. When we split them, it's the same as the left. So the right is the same as the left. Now this is type 1. So if I do an example, I'm trying to split it so that we can go ahead and integrate this. So having this, I'm going to split it as a over the first bracket plus b over the second bracket. Now, for this fraction, we're going to find out what is the value of a and what is the value of b. So in doing this, I'll have to find the LCM and then compare the numerator. Now let's look at numbers when we find the LCM. So I have a half plus 2 over 3. The LCM you'd say is 6. And then we say 2 into 6 goes 3 times. And you multiply the numerator here by 3. So 3 times 1 will give us 3 here. It's the same scenario here. The LCM will be the two brackets we have here, which is x plus 2 and x minus 3. So let me write the x plus 2 and the x minus 3. So now we're going to say x plus 2 into the denominator. The two x plus 2 cancel. So we multiply the numerator a by x minus 3. So we're not going to expand out the bracket. But what we're going to do, we're going to just write the a times x minus 3. Now, same thing we're going to do with the x minus 3. We're going to divide x minus 3 into the denominator. The x minus 3 cancels, so we're just left with x plus 2. And we multiply b multiplied by x plus 2, but we're not going to expand this. So we're going to write it as is. Please note that this is the same thing as the fraction that we have, which is 3x plus 1 over x plus 2 times x minus 3. So I'm going to equate the numerators to be equal because they are the same fraction. We're just finding out what is a and b. So by comparison, I equate the numerators to be equal and I am going to find the values of a and b. Now I'm going to use substitution of a number. I'm going to let x to be 3 because right here, if I put x to be 3, it becomes 0 where I have a. So I'm going to replace x to be 3. So I have 3 times 3 plus 1 equal a. Then I have 3 minus 3 plus b. Then 3 plus 2. Now 3 minus 3 is 0, so that's what I'm saying. This should be gone because a times 0 is 0, and we want that so that we can find b. So 3 is 9, plus 1 is 10, 3 plus 2 is 5, so we have 5b. Then we divide both sides by 5. This cancels, the b is equal to 2 because 10 divided by 5 is 2. So we're going to do the same step to get rid of b because we know what is b now, so we assign x to be negative 2 and then we can find out what is a. So substituting 3 open bracket negative 2 close bracket plus 1 is equal to a open bracket, minus 2 minus 3 plus b, open bracket, minus 2 plus 2. So once again, we're getting 0, and 0 times b, that's gone. So what do we have? We have minus 6. 3 times negative 2 is minus 6 plus 1, that's negative 5, is equal to minus 2 minus 3, that's minus 5a. Then we divide both sides by negative 5. And this cancels, so a is equal to 1. So what do we have? We have 3x plus 1 over x plus 2 times x minus 3. Rewriting this as a partial fraction, now that we know what is a and what is b, it's equal to a, which is 1. So I replace a, so it's a is 1 over x plus 2, and I know what is b. B is 2, so I'm going to replace it, 2 over x minus 3. Now usually when we have something like this, we usually ask you to integrate it. That will be the next question. So we would ask you to integrate this fraction after expressing it as a partial fraction. Now, first thing first, I'm going to rewrite this. So it is the same thing as 1 over x plus 2 plus 2 over x minus 3. So if we're integrating this, we express it as the two fractions that we just created. Then we're going to integrate them individually. So we'll have the integral of 1 over x plus 2 plus the integral of 2 over x minus 3. Now don't forget your dx. Dx means you're integrating with respect to x. Now when we're integrating partial fraction for type 1, we'll use the integral of fraction form where we have the derivative in the numerator. So fx is a denominator and f prime is the derivative of the denominator. So when I'm trying to get this format, it will give me ln fx plus c. So the first one is in the form where the derivative of x plus 2 is 1. So therefore the integral of this is just ln x plus 2. Here, when I differentiate, I'm not getting 1. So I will have to carry out the 2 outside. So in other words, this is the same thing as 2 times the integral of 1 over x minus 3. So we have to have the derivative in the numerator for us to see the integral of this is an ln function. So now I have it, so I can write this as plus 2 ln x minus 3 plus c. And that's it. Thanks for watching, guys. Don't forget to like and subscribe to my channel. Have a great day.